Welcome to Spring Lib.
In this question, given data is there is a projectile given which is fired with a speed u and angle of projection given that is making with horizontal field that is theta. So you can see that this is a projectile with fired by u speed and angle is that is theta. So now in the question it is saying that the coefficient of restitution is given, that is equal to E, and in the question it is asking that we have to find the distance for second collision from with respect to starting point, distance between starting point and second collision. So this is the question, this data is given. Now let's start answering this question. So in the answer I can say that here you notice this figure, so you can understand that what is a second collision, what means that is second collision. So I can say that here the projectile is fired with u speed and angle of projection is that is theta, so it is taking a first collision here by hitting the ground first time. So and then after it what happening is it take another collision, that is hitting the ground second time with speed that is considered that any speed that is u dash after a collision, first time collision, this projectile is going with hitting the ground second time, so I can say that this is a second time collision. So now in the question it is saying that we have to find distance between starting point to second time collision, so that means we have to find x. So now I can say that in the answer the initial velocity of a projectile is before taking a collision. I can say that initial velocity of projectile is given, that is equal to u, and angle of projection is that is equal to theta. So now I can say that this projectile is going to hit first time. So by here, again I am here doing this figure. So this projectile is going to first time hitting here with speed u. So then you can see that the horizontal component in every projection remains same. That means the here horizontal component of this speed, initial velocity of speed will be, that is this is a theta, so I can say that u cos theta horizontal component will remain same, but here the vertical component is changing. So that means we have to find out the vertical component for second collision. So I can say that after hitting the first time, the this is a velocity of separation, assume that this is a v, and this is the speed, that is assume that u dash by hitting to second time the ground. So I can say that this distance is x1 and this is a x2 distance from a starting point to first collision. I can say that distance is that is x1, and from first collision to second collision distance is that is x2. So now I can say that the horizontal component will remain same in every collision, but the vertical component is changing. So my next step is here I will try to find the speed for second collision. So for finding this speed, that is u dash, here we have to requirement of horizontal component and vertical component. So I can say that the horizontal component of speed u dash will be, that is as I already written in the above line, that is always same. So I can say that is equal to u cos theta, and the vertical component of speed will be written as, by using the coefficient of restitution, I can say that is equal to eu sin theta. So because we know that velocity of separation, this is a vertical component, means in other term I can say that after first collision this velocity v will become, that is velocity of separation. So by using the coefficient of restitution, here I had get the vertical component, that is eu sin theta. Now next step is the, I can say that u dash will be written as, that is square root of horizontal component square plus vertical component square. So horizontal component is, that is u cos theta square plus vertical component square, that means eu sin theta square. So now next step is for second collision. Here you can say that this is also following a path of projection. So here I will try to find angle of projection and assume that this is a alpha. So by using the general equation for projection, I can say that angle of projection will be written as alpha, that is equal to tan inverse times of vertical component divided by horizontal component. So vertical component is, that is eu sin theta divided by horizontal component, that is u cosine theta. So simplify it, then I will get the alpha, that is equal to tan inverse e tan theta. So or I can say that it will be written as in the other way, that is tan alpha is equal to e tan theta. And we know that tan alpha is equal to, that is we know trigonometric identity, that is 1 plus tan square alpha is equal to sec square alpha. So this is a trigonometric identity. So use this in above step. So I can say that sec square alpha will be written as, that is 1 plus tan square alpha will be, that is by using this I can say that put here value, that is 1 plus e tan theta square, or I can say that it will be written as, that is sec square alpha is equal to 1 plus e square tan square theta. So now next step is write the equation of projection. So it will be written as, that is general equation is, that is y is equal to x tan alpha minus gx square sec square alpha divided by 2 u dash square. So here x is, that is x2. So now put the value of sec square alpha in this equation which I get in the above step, that is sec square alpha is equal to 1 plus e square tan square theta, and put the value of y2 that is equal to 0, because here I will try to find the value of x2. So at x2 distance you can see that the y2 will be that is equal to 0. So I can say that here I am putting the value of y that is equal to 0 in this equation, and put the value of sec square alpha, and also put the value of u dash which I had written in the above step, that is this value in above equation, in this equation. So it will be written as, after putting value is, that is 0 is equal to x2 tan alpha will be, that is I can say that by using this equation which I had get in the above step. So here we have to also put the value of tan alpha. So I can say that 0 is equal to x2 multiplied by tan alpha will be written as, that is e tan theta minus g x2 square, and sec square alpha will be written as, that is 1 plus parenthesis of 1 plus e square tan square theta divided by 2 u dash square will be written as, u dash square will be, that is in the bracket I can say that u cos theta square plus eu sin theta square. So now simplify it, then I will get the x2, that is after simplifying final value of x2 that is equal to, that is eu square sin 2 theta divided by g. Now in the question it is asking that we have to find the distance between starting point and second collision. So I can say that it will be written as, that is distance between starting point and second collision will be equal to x1 plus x2, and x1 will be, that is horizontal range, and we know the general formula for horizontal range. So I can say that put here formula. So value is, that is u square sin 2 theta divided by g, where u is the initial speed and theta is the angle of projection, and plus now put the value of x2 which I had get in the above step, that is equal to eu square sin 2 theta divided by g. So after solving I will get the distance, that is taking a common u square sin 2 theta divided by g, then inside will be written as, that is in the parenthesis I can say that 1 plus e. So this is the answer for given question, that is distance between starting point and collision, second collision is, that is u square sin 2 theta over g times of 1 plus parenthesis of 1 plus e. Thank you.